Hi everyone, welcome back. Today we're going to be looking at standard 6.EE8.A3. Apply the properties of operations to generate equivalent expressions, which is pretty much just order of operations. Now let's think about when you're getting dressed. Does it matter if you put your shoes on first, or does it matter if you put your socks on first? Does order matter in this case? Can you put your shoes on and then your socks? Well, we know that realistically, right, you'd put your socks on first and then your shoes. So in this situation, order does matter. And it's the same concept behind order of operations. When we think about doing math problems, the order in which we do the math problems will matter. So let's look at our vocabulary terms. Order of operations tells us how to do a math problem with more than one operation in the correct order. And when we talk about operations, we're talking about addition, subtraction, multiplication, or division. Numerical expression, a mathematical phrase that includes only numbers and operation symbols. So here you wouldn't have any variables or any of that in a numerical expression. To simplify is to find the value of a numerical expression. So when we talk about equations that have equal sign, we say we solve those. But when we talk about expressions, we say we simplify an expression. Now, some of you may have heard of PEMDAS, but for our purposes, we're going to look at GEMDAS. And the difference between PEMDAS and GEMDAS is just the P and the G. So in PEMDAS, the P represents parentheses. In GEMDAS, we're talking about all the grouping symbols. So parentheses, curly braces, brackets, fraction bars, all of those are considered grouping symbols. So we wanted something a little bit bigger that would encompass all of the symbols that could be used as a grouping symbol. Absolute value bars, right? All of those are a part of our grouping symbols. Now, I want you to construct this graphic organizer here. And what we're going to do is to pretty much put the letters in for each. So the first thing that you must do whenever you're doing order of operation is to do your grouping symbol. So if that's a parentheses or whatever, that goes first. After you've done whatever's in your grouping symbol, then you're looking at your exponents. Okay, so that's your squared or your cubes. Okay. Now, when we talk about multiplication and division, we go from left to right, just like how you read. You read from left to right. So whichever one comes first is what we would do first. So here we have multiplication and division, but it really could be that division would happen first and then multiplication would happen second. It just all depends on which one appears first in the problem. So both of these go from left to right. And we'll see the same thing for our addition and subtraction. So they go addition and subtraction, and it's from left to right. So either of them could happen first. Okay, so grouping symbols first, then exponents, then multiplication or division from left to right, then addition or subtraction from left to right. Now, some of the grouping symbols to really keep in mind: parentheses, your brackets, your braces, your absolute value bar, radical symbols, right? So taking the square root of a number, and the fraction bar. So make sure you have these all copied down because these are grouping symbols that you want to keep in mind. It's not just limited to parentheses. So let's go ahead and take a look at a few of these examples, right? So you have GEMDAS up here, grouping symbols first, exponents second, multiplication and division from left to right, addition and subtraction from left to right. So here, when we look at the problem, 3 plus 2 to the third power minus parentheses 9 plus 1, close parentheses, here I have a grouping symbol. So this means I'm going to complete what's inside the grouping symbol first. So 9 plus 1 is 10, and then I can bring down the rest of the problem. Okay, now I've completed my grouping symbol. Now what I have next would be my exponents. So here I have 2 to the third power. So 2 times 2 is 4. 4 times 2 is 8. So we talked about that before. Exponents, this would mean 2 times 2 times 2, right? So 2 being multiplied by itself 3 times. So 2 to the third power is 8. and I'm going to bring down my plus and my minus 10. So I just completed my exponents. I have no multiplication or division, so I'm not going to touch that. Here I have addition and subtraction. I'm going to go from left to right. So 3 plus 8 is 11 minus 10. 11 minus 10 is 1. So my final answer for this example would be 1. Now let's follow that same process here. So again, I'm doing my grouping symbol. So 9 plus 1 is 10. And because I have this 3 on the outside and I know that's multiplication, I'm going to rewrite this product inside the parentheses just to show that I'm multiplying. You could have also inserted a multiplication symbol here. That's completely okay. So I completed my grouping symbol. Now I'm going to do my exponent. So 6 squared is 6 times 6, so that's 36. Okay, and I'm going to bring down my 3 times 10. So I completed my exponents. Now I do have multiplication. 3 times 10 is 30. I have no division, but I do have addition. Okay, so 30 plus 36 is 66. So here my final answer would be 66. All right, let's take a look at some more examples. So here I have no grouping symbol, so my first step is going to be my exponent. 2 to the third power. 2 times 2 times 2 is 8. And then I like to bring down the rest of the problem. What that does is it ensures that you do not forget anything that you need to do. So no grouping symbol, exponent completed. Now we do have multiplication, so let's go ahead and complete that. 10 times 8 is 80. And then we bring down the rest of the problem. Some people might say, oh, that's too much work to have to keep rewriting it. But trust me, it helps you to remember all of what you need to get done. You don't forget any parts of the problem. Okay. Now there's no division, but we do have addition and subtraction. So we go from left to right. 4 plus 80 is 84 minus 16. And then now we have to do that subtraction. 84 minus 16 is 68. So our final answer here is 68. So we had addition and we had subtraction. Now let's take a look at the next problem. So again, we do have parentheses, so we're going to do what's inside the grouping symbol first. But if you notice, I have more than one operation inside the grouping symbol. I have multiplication and a subtraction. So I'm going to go ahead and do that multiplication first, okay? So I can say 9 times 3 is 27. And I'm going to bring down that 19 and I'm going to put it back inside the grouping symbol because I still need to finish up everything that's inside the grouping symbol. And let's bring down the rest of it. Okay, so now 27 minus 19. So we're still on that grouping symbol. 27 minus 19 would be 8. And then we're bringing down the rest of the problem. Okay, here now we have division, so we can go ahead and complete that. 64 divided by 8 is 8, and that's your final answer. So Jacob solved the problem 4 squared minus 2 times 3 plus 6 below. What mistake did Jacob make? Show the correct solution for the problem. So whenever I have these type of problems, I always like to do the work first. And then I can compare my work to what the other person did to see what their mistake was. So I'm going to start off by just writing the word GEMDAS, or say the acronym GEMDAS, so that I can ensure that I keep track of all I need to get done. Okay, so here I have 4 squared minus 2 times 3 plus 6. I have no grouping symbols, so I can move past that. However, I do have an exponent, and I know 4 squared is 16, and I can bring down everything else. So I completed my exponent. Now I do have multiplication, 2 times 3. 2 times 3 is 6. So I can eliminate that, and then bring down everything else. Now I have addition and subtraction from left to right. So here I am going to subtract first, even though the S is written last, because I remember that they're on the same level from left to right. So whichever one comes first, that's the one I will do first. Does it matter? Yes, it does. So 16 minus 6 is 10 plus 6, which would give us an answer of 16. Now, if we take a look at Jacob's work, we'll see that where Jacob made the mistake is on this level. So here Jacob said, okay, I'm going to add first and then subtract. That's the reason he ended up with an answer of 4. 6 plus 6 is 12, but 16 minus 12 is 4. Now, if Jacob was familiar with integers, he would have seen that this was a negative 6 and this was a positive 6. So that would have actually canceled out to 0. And then, right, he would have had 16 plus 0. But we'll talk about that further when we get to integers. So here, he did not follow the order of operations, and that's the reason he had an incorrect answer. So here, he decided to add first instead of subtracting. So our answer is correct, and we were able to clearly identify what Jacob's mistake was. Thank you for watching and have a great day.